Welcome, and thanks for giving me the chance to share my project. And today I'm going to talk about my protein structure motif detection tool for Folddisco. And the developer of Rosetta Fold and AlphaFold 2 won the Nobel Prize in chemistry this year. And by collaborating with EMBL, the AlphaFold team could predict all of the structures of proteins in the UniProt database. And thanks to these protein pioneers, we now have hundreds of millions of structures. Despite of this kind of revolutionary structure predictions, still 28% of the database is still uncharacterized. And even with the well-known sequence-based annotators like Interpro or other sequence aligners, still we have 54 million uncharacterized proteins and also 3.7 million hypothetical proteins in this database. And protein structures motifs can offer functional insights to this kind of unannotated proteins. Like discontinuously functional structures motifs such as serine peptidase or zinc finger motifs can give insights into the functions like endopeptidase or like DNA binding properties. So to utilize this kind of structure motifs, RCSB developed a motif search algorithm based on representing the motifs as a list of pairwise features. And RCSB's pairwise feature consists of two distances, one with C alpha distance and the other is between the C beta. And also they use the intersecting angle of these vectors. What they did is building an inverted index out of the pairwise features. And inverted index maps the features to the structures and the occurring locations. So it enables the search in almost instant. So RCSB's structure motif search is kind of valuable resource, and the service is available in the web server, and it's based on 55 gigabyte storage of index that consists of 160,000 structures. However, there's a problem like this RCSB's method cannot be scaled to 200 million of structures that we now have. From the extrapolations, it would require about 100 terabyte storage to build the index for the AlphaFold database with RCSB's method. And 100 terabytes is quite a burden for the average research groups. So to tackle the scalability problem, we developed Folddisco. And Folddisco is free and open source Rust software, which is available at this link. And our development goal is to build a tool to reduce the index size and accelerate the speed for the indexing and querying, and to improve the precision and recall for the queried results. So Folddisco works like this. It starts with getting the pairwise features from the structures between the proximal residues. And we get the feature vector and we hashes it into 32-bit integers. And Folddisco build inverted index out of the hashes. And when querying, we also get the pairwise features from the query motif and we hashes, and we search the hash in the inverted index. And finally, we do the superposition and calculate the RMS, then report the result. To reduce the index size, actually the required storage size, Folddisco supports FoldComp. And FoldComp is protein structure compression tools that utilize backbone torsion angles. And with FoldComp, about 90% of space can be reduced for saving the structures. As you can see there, the raw PDB file for the Swiss prot takes about 144 gigabytes, but it can be reduced to 3 gigabytes with FoldComp. And another strategy to reduce the storage size is omitting the feature occurring positions in our index format. RCSB's inverted index format is a word-level inverted index, which saves the structure and also the occurring positions. However, Folddisco omitted the locations, so it's kind of record-level inverted index. And in combination with the data encoding and the deduplication from the record level index, we could reduce the required storage space for the index by 70%. So we had the indexing benchmark against the RCSB's index and PySco Motif. PySco Motifs is a Python implementations of RCSB's method. And so as you can see there, the Folddisco index was the smallest among these tools. And for building the index of the PDB databases, Folddisco requires about 23 gigabytes compared to the other tools required over 50 gigabytes. And also, Folddisco was the fastest in indexing. And to build index of SwissProt, which contains 500,000 entries, it only requires about 55 minutes with 12 threads. And FoldCompDB support reduced the required storage for the index and also the structures. So for the SwissProt, the FoldCompDB requires 3 gigabytes and SwissProt requires 31 gigabytes. So it's total 34.6 gigabytes. So to achieve the remaining goal, high precision and recall, we improved the pairwise features and introduced new ranking metrics. For the pairwise features, RCSB's method are missing the sidechain orientation informations because that's kind of important because the functional motifs, to be functional, the sidechain should be like oriented in certain orientations, but yeah, they are missing this. So Folddisco features added these 2 sidechain torsion angles. And also we have encoded all the angles with sine and cosine values to retain the cycling nature of the angles. And for the new ranking metrics, the TF-IDF, it's actually term frequency and inverse document frequency, and the product of the 2 values is kind of widely used metric for ranking results from inverted index. And IDF is related to the rarity of the features. So Folddisco used some IDFs of feature hashes to give more weights to distinct and rare features. And these ranking metrics help to filter out the false positives in the latter part of the process. And also we've added a length-based penalty to avoid the random matches in long proteins. And so we have done querying benchmarks against the PySco motif and RCSB. We queried the serine peptidase motif and zinc finger motifs against the human proteome. And as RCSB had a problem with fully utilizing the 4 residues of the zinc finger motifs, we used only 3 residues in this figure. And in this setting, Folddisco was the best in finding serine peptidase and the second place in finding zinc fingers. However, when I applied the 4 residues, Folddisco didn't suffer like query-dependent performance drops like PySco motifs or ICSB. Also, the querying speed was quite faster than PySco motifs. So yeah, so these were the developmental goals, and we kind of achieved, and we built an index of the sequence clustered alpha4DB, which is named the AFDB50 because it used sequence identity 50 cutoff. And to build this database of 50 million entries, it required 1.6 terabyte storage with FoldCompDB included. And the searching for zinc finger motifs against this database took about 1 minute and 30 seconds for getting the 760,000 targets. And we have explored the alpha4DB indexes, and Folddisco found zinc finger motifs of totally uncharacterized protein in these databases. This is one example, and K1RNK4 is a protein from Pacific oyster, and this protein does not have any information like interpros or domain annotations and homologs informations, but Folddisco could found 2 zinc finger motifs from the structure. And yep, this work was done by with guidance of Professor Martin Steinegger, and Milad and Rachel helped a lot during the development process. And yeah, we brought 5 posters to this conference. Please check our labs posters. It's on the section 3. And next year, the RECOM is happening in Seoul, Korea in April. So please save the date. And thank you for listening.
Thank you very much. We have 3 minutes for discussion. Is there any question or comment? Okay, I
have a question. Can we use your tools for kind of RNA structure or other non-protein structure?
Yeah, RCSB's motif search supports RNA, but current version of Folddisco doesn't support RNA yet. And yeah, I'm going to work on that, and also thinking about adding the inorganic atoms also. So thinking of that. Then.
Thank you.
Thank you for comments.
We can still accept 1 or 2 short questions. What do we miss if you ignore the positional information of motifs?
Yeah, I don't save the occurring positions, so it requires additional computation to match the residues where the motifs are happening. So yeah, it has additional computation during the querying, but still the querying process was faster than other tools.
We can not detect a very large kind of motifs in that case.
If the motifs gets larger, actually the pairwise feature gets quadratic. So yeah, it gets slower.
Okay, thank you.
Yeah.
So we move to the next talk. Thank you very much.